Hi, welcome to your lesson on domain and range. This is a very blurry kind of image, but hopefully after watching this lesson, you will have a less blurry understanding of domain and range. Let's get rolling. So let's remind ourselves where we ended off recently. That was the definition of a function. A function is a specific type of relation where every element of the first set, which are the inputs, or also known as the independent variables, is mapped onto one and only one element of the second set, which is known as the outputs or the dependent variables. That was a long definition, but all it means is that when you have a relation between things, if each input leads to only one single output, that is called a function. And we had this idea of functions here. Here you can see all these inputs here. Each of those inputs, even though they lead to the same output, they each only lead to one output. Over here, each input leads to only one output. These are functions. This one is not a function because you can see the input 6 leads to two different outputs, not a function. Okay, so now that we have reminded ourselves what a function is, let's talk about domain and range. The domain of a function is all the possible values of the independent variable. In other words, all the possible inputs. Okay, that's the domain, all the inputs. The range of a function is all the possible values of the dependent variable. So all the outputs, okay? Inputs, outputs. Okay, so if we have this function here, the domain is simply these three numbers. It is the inputs, and the range is simply these three numbers, the possible outputs. Okay, simple. Over here, so this is a mapping diagram. Here's a graph. On a graph, if we graph a relation, the domain is all the inputs or independent variables, right? So that would be all the possible x values. So when you look at this graph here, it begins here, it ends here. So the possible x values begin at whatever value that is. And all these ones show that all these are possible x values, and then it ends here. So that's the last possible x value. That's our domain, from whatever value to whatever value here. Our range is all the outputs or dependent variables, so the y values right here. The range here goes from this lowest point up to this highest point. So that's the range of values that are possible. Okay, so let's talk about domain and range related to all these representations we've looked at. One type of representation we had for relations or functions was a table of values. So we have a table here, here, here. Let's assume the top row is our inputs and these are our outputs. So the domain, therefore, is these values here, the possible inputs right here. This set of numbers is our domain. And the range is this right here, 1, 3, 5. Notice the 5 is only listed once because it repeats. We don't have to list it twice. This set of numbers is our range, our outputs. Easy. Okay, here's a mapping diagram. What would be the domain for this one? Well, the domain would be, again, this set of possible inputs, these values here. We can see them here. And the range is all the possible outputs, 4, 6, 8, right here. Okay, pretty straightforward, right? Inputs, outputs, domain, range. Another representation we had of relations or functions was a set of ordered pairs. So we can see here a set of ordered pairs. Here's just a set of single values, right? But this is a set of ordered pairs. So what's the domain? Well, all the inputs. All the inputs are -3, -1, 3, right? And the outputs here are these numbers, 5, 9, and 5. So there's our possible outputs, our range. Notice we listed just 5 and 9. We don't have to repeat the 5. Great. Different representations, domain and range works the same way. Another representation is a discrete graph, right? A graph where you plot your points, your possible discrete values. There they are. Okay, so domain is all the x values, all the inputs, -2, -1, 0, 2, 3. There's our domain. What's our range? Well, all the possible outputs, -2, 3, -6. Here they are. Okay, pretty straightforward, I hope. The final one, and it's a little stranger at first when you see it, is, okay, we have another representation of a function, is a equation. So we have an equation here. What's the domain? Well, it's not so obvious like it was with these other ones where we see the values literally listed there. But think of this. What is this graph at? This is a linear equation. Therefore, it graphs as a line. So imagine graphing a line. When you graph a line, it has arrows at each end, right? Those arrows imply the line goes forever in both directions. Well, if a line goes forever now, visualize that in your mind, what are the possible x values? Well, the possible x values we're going to write like this. Basically, all the x values, any x value is possible. You can put in any value of x in here, and the function will work. You will receive a y value, right? Anything you put into x, it will work. So x is an element, this means element, of the real number set. X can be any real number. It means it can be any positive, negative, decimal, fraction, any number we can think of, x can be that number. And that means the line goes forever in both directions. So that's domain. Another way to write that is here. We can say x values can be anything from negative infinity to positive infinity. All right, and this is another way to write it here. Means x can be, yeah, it can be any value from negative to positive infinity. Same thing for the range. Y is an element of the real number set. Y values can be anything. If x can be anything here, y can be anything as well. It's easier to see that often graphically, but let's move on from there, and this will show it graphically a little bit. So we had our domain and range, and now let's define the difference between discrete and continuous data. Discrete data is graphed as separate, distinct points. This is discrete data. You can see separate points. And continuous data is graphed as lines or curves. Why? Why is this called continuous? Well, when we have a curve like this, there are actually points on it, right? Here's some points. There's infinite points. Imagine drawing infinite points here and then connecting them. That's what a curve represents. It represents infinite points. So continuous data is graphed like that. It just represents infinite points, all right? So now let's talk about domain and range. Let's say this began at 3 and went to 17 here. And then we could say the domain is x values from 3 to 17, right? Let's say this went from 2 to 13. Then we can say the range is y values from 2 to 13. So here's how we would show that. Oh, let's see what I got. Okay, sorry, just setting it up. Okay, domain will look like this. We say x such that means the domain is all the x values, but we're putting a condition on it. And the condition is x can only be values from 3 to 17. From 3 to 17, that's what this means here. X is greater than or equal to 3, but less than or equal to 17. So from 3 to 17, and we can see that x values can be from 3 to 17. And now we're not writing that x is 3, 4, 5. We're not listing the points. We're writing it like this because this implies that x can be any value from 3 to 17. That means any decimal value, any fraction in between 3 and 17, any value between 3 and 17. That's what this shows. Therefore, the range for this one is y such that y is between 2 and 13. From 2 to 13 is all the possible y values. Again, shown with these symbols, these inequality symbols, meaning that y can take on any value between 2 and 13. Okay, so that's how we show continuous domain and range. But for discrete data, we don't need to use those symbols. We can just list the exact values these can be. For example, the domain here is this set of numbers: 5, 7, 9, 11, 13, 15. All right, those are the possible x values. So we list them all because we cannot say x can be any value in between. It's just those distinct values. And then for y values, I kind of showed it went from 7 to 12 here. So I listed the values between 7 and 12. I know I'm not being super precise here, but let's pretend that every value, 7, 8, 9, 10, these points take on all those values in between. So again, very important, continuous, discrete. When we have discrete data, we can list the values. When we have continuous, we need to show it as values between, like that. Okay, so let's look at this one here. This is a solid point at the beginning of this graph here. And here we have a hollow point. It's important to know the difference. When you have a solid point, it means that value is included. And when we have a hollow point like this, it means the graph gets to that point but doesn't quite reach that exact location. That's like an empty space. Okay, so how do we show that? Let's talk about this. So what is the smallest x value that this graph has? Well, that's -2, right? If you look at the x-axis, this is the smallest value possible. Okay, what is the largest x value? It is a value just below 1, right? It's not 1 because there's a circle. If you said 1, you're right, but not quite right, right? Yes, the x values go all the way to 1 here, but they don't include 1. They get to just before 1, so just below 1. Okay, write the domain, therefore, based on that. Well, the domain is this: x values such that x lies between -2 and 1, right? Goes from -2 to 1, from -2 to 1, including -2. That's why we put this equal sign here. But notice there's no equal here. less than 1, not including 1. This is greater than and including -2. This is not including because we get to there. Great. Try the same thing for range. So notice again here, the solid point included, and here the hollow point not included. Okay, so what is the smallest y value? Well, it is -1. We can see the graph. This is the lowest point here, -1. And what's the largest y value? Go all the way to the top. Oh, it's 3, right? Okay. Are both of those included? Yeah, there's no empty circle there. It's an included point. This is included. So what's the range? The range, therefore, is y values such that y is between -1 and 3, included on both, because that's an included point, and so is this. All right, try the same thing here. What's the smallest x value? -5. You can see the graph begins here and goes that way. See, -5 is the smallest possible x value. What's the largest possible x value? Little stranger to answer that one, because this graph, as you follow it, there's an arrow there. There's not a point or a hollow circle. It's an arrow. So that means that graph would forever go diagonally in that direction. If it forever goes that way, it will forever be going along the x-axis, right, until infinity. It will just go forever diagonally. Therefore, x values go to infinity. Okay, what is the domain then? Well, x such that x values must be greater than or equal to -5. Okay, because x values can be anything -5 or greater right here. Okay, what's the smallest y value? Same as with the x. When this goes forever in this direction, that means on the y-axis, you will be traveling forever downwards, all the way to -infinity. Therefore, the smallest y value is -infinity. Now you're looking up, up, up. What's the largest y value? The largest possible y value is 5. This graph goes all the way to 5 here. There, but it ends there. Okay, so what's the range? The range is y values less than or equal to 5. You begin at 5, go down. All that is possible for y. Awesome. So now we have this function here, and it says this function exists only for these x values. Okay, so find the image of x equals -0.5. Image means when you put an input in, the image is like your output. So what's the output when you put that in? Okay, great. That one, if you put -0.5 in here, you get an answer of 0.5 for y. So that's your image. Write down the domain of this function. Okay, I hope you didn't make the mistake of saying all real numbers. We talked about a line before and how it has a domain that's all possible x values, but not in this case. In this case, it tells us a line, yes, and a line would be go forever in both directions, except for it limits our line here by doing this. It's called a domain restriction. So that's our domain. All right, it's telling us x values can only be those. Okay, so that's the domain. How about C? Use your GDC to help you graph this one. Let's try that. I'm going to open my GDC 1 second. Okay, here's my calculator, and I'm going to graph it. So we're going to press y equals, do the same thing on yours, and we're going to enter the function x plus 1, and now we want to set up the domain as well. So it gives us a domain here, so I'm going to do a domain a little bit less and a little bit higher. So I'm going to go window. I'm not saying the domain, sorry, I'm setting the graphing window, right? We want to look at the line between -2 and 1. So why don't I just put a x value from -3 to 2. So I'm going a little bit before, a little bit after. We're going to graph a little bit before and after to see what it looks like. Let's see what that graph looks like. Oh, my window is set up a little bit differently also for y values. So let me go back to the window. I want to see some lower and higher y values, maybe y min. Why don't I go -5 and all the way to 5? So for y values, I want the graph from -5 to 5. Let's see. Okay, that's a better graphing window. We can see that line. However, this domain restriction has not been applied. It graphs the whole line, and the calculator is going to do that. It doesn't graph just between 2 points. But I want to know what those 2 ending points might be. So here's something you can do to find out. Okay, if we are taking x value of -2, you can put it in here, of course. Put -2 in here, because that's our beginning point for the graph. Okay, put -2 in here. What do you get? Well, -2 put in here gives us -1, right? We can do that on here also. Press second trace, which is going to go to calc, and we can do value, number 1. So we're going to say when x equals -2, what's the y? And it tells us right here, when x is -2, y is -1. So that tells us where the graph should begin, at -2, -1, because that's where the beginning x value. Now let's do the same thing for the upper x value, 1. So if you put a 1 in here, what do you get for y? 1 goes in there, you get 2 for y. So you know your starting point is -2, -1, and your ending point is 1, 2. Okay, so when you do the graph, it should look like this. So this is important for the IB kind of exams. They often do this. They say, here's a function, and if you graph the line, you graph it going forever, and you put arrows on the ends to show it goes forever. But here it says graph it only from -2 to 1. So that's what we did here. Here's that starting point, x value of -2. Here's the ending point, x value of 1. And we found out the y value here is -1, and the y value here is 2. So we kind of have those 2 points, we connect them, we have our line. Okay, so what's the range of this function? So it says hence, that means based on this domain, we now have a set range. What is it? Well, the range is from -1 to 2. Those are our possible y values. Okay, simple, but also maybe something new to you, so make sure you understand how to graph just a portion of a line using these techniques, and then talking about domain range. Great job, we'll see you soon.